Hello, good morning, or afternoon, or evening, depending on when you are reading this. I would like to go through the final page on that note sheet that you received. And what I would like is for you to follow along with me on that note sheet that you already have, or on that same blank sheet of paper that you already used from Monday, in order to complete the rest of these notes. So you should be missing the finding angles portion of it, but also the last two problems where we are going to use the law of sines to solve for a missing angle rather than a missing side length. So the only difference with the law of sines regarding when we're trying to find angles is we are simply going to flip where we put our items. So we still have A, B, and C as our side lengths, and we still have angle A, B, and C, where they all correspond to, well, A and A, B and B, C and C. So as opposed to with the finding sides, we are going to flip it. So it's going to be the sine of A divided by lowercase a is equal to the sine of B divided by lowercase b, and that is equal to the sine of C divided by lowercase c. And we're going to use that law of sines. Now, they are the same thing. All I did is flip them, but as long as I flip all of them, we are still treating this as equal. So I'm going to use this in order to solve my problems today, and you will be practicing it in some form as your assignment for Friday. So moving on to the last but not least piece is we've got a first problem here where we're trying to find missing angles A and missing angles B. Now, we are going to have to consider what's in my picture. What am I given? Well, I always need to know that opposites go across from each other. So 5.5 matches up with angle C, which is 63 degrees. The side length of 4.7 matches up with B. And the angle A matches up with, well, we don't know what side length A is. Now, again, the point here is we're not trying to solve for that side length. We are simply trying to solve for angles A and angle B. Now I need to know as many of these pieces as possible. Obviously, since I'm trying to find angle B, that's unknown. The nice thing is that I know a side length 5.5 and an angle of 63 degrees. They are paired together. So I'm always going to use those two in my solution. But then I need to consider, okay, well, I need to pick another angle side pair that provide me with some type of information so that I can actually solve for the missing angle B. And in this case, like I said, A is non-existent, so I can't use angle A and side length A. I need to use angle B and the side across from it. So that's the 4.7. So like I did before, we're always going to set it up. And what's different is we're going to put the sine of our angles first on the numerator, and we're going to put the side length in the denominator because we know what the side lengths are going to be, and we are trying to solve for this angle. So really, we're only going to be doing two big algebraic pieces, and I will show you those. So here we go, step by step. First step. Let's set it up. So I'm for sure going to be solving for angle B, is what I said. So we're going to start by saying the sine of B divided by the corresponding side length, which happens to be 4.7. And that is going to be equal to our pair that we know. So that's the 5.5 and the 63 degrees. So it's going to be the sine of the angle, which is 63 degrees. That's a bad 3. divided by the corresponding side length, which happens to be 5.5. From here, remember, I'm trying to solve for b. I'm trying to isolate b here. So first I should get sine of b by itself, and then from your previous experience, we know that we're going to have to do the sine to the -1, or the inverse sine of both sides in order to solve for angle b. So first, let's isolate sine of b. How do I get rid of the 4.5 in the denominator on the left side of the equal sign? How do I get rid of that 4.7? Well, if it's in the denominator, I should multiply both sides by 4.7. So I'm going to do 4.7 times the sine of b divided by 4.7. That cancels out, and that's equal to the sine of 63 degrees divided by 5.5. But this is being multiplied by 4.7, right? Because we have to do it to both sides. So I'm multiplying by 4.7. Now, from here, right, remember this canceled out, so I'm just left with sine of b now. So sine of b is equal to 4.7 times the sine of 63 degrees divided by 5.5. Now, it doesn't really matter what that number is, because essentially what we're going to do is we're going to take the inverse sine of both of these sides. Now, for the sake of showing all my work, I will calculate that for you, but what I would suggest is just taking this number, just typing exactly what that is into your calculator, but hitting the sine to the -1 first, and then typing that inside of the parentheses, and then hitting enter, because you will find your angle that way. But I will show you the step-by-step. So next we've got sine of b is equal to, and now let me calculate, so 4.7 times the sine of 63 degrees, that gives me 4.1877, divided by 5.5, and I get 0.7614. So that equals 0.7614. Now remember, I'm trying to find just angle B. So in the way that I can undo this sine function here is by doing the inverse sine of both sides. So I'm going to do sine to the -1 of both sides. So the sine of B and 0.7614. Now this is going to take us up here. And once I did that, essentially that is undoing, right? The sine gets eliminated and I'm just left with a B. So B equals, and now I need to compute that on my calculator. So the inverse sine, remember you got to hit the blue button second, which is the top left button, second, and then sine, and that gives you sine to the -1, inverse sine, of 0.7614. Hit enter, and I get 49.5877. So 49.6, I'm going to round it to a tenth, so 0.6 degrees. And that is angle B. So this goes right there. Now, could I do the same process to figure out what angle A is? Still no, because I don't know what the opposite side is. So I could find that opposite side, but we can't forget about prior knowledge, right? We know that in a triangle, the angles add up to 360 degrees. So it should be true that 63 plus 49.6 plus angle A should equal 180 degrees. Well, 63 plus 49.6, that is equal to 112.6 plus angle A should equal 180 degrees. We are trying to find, how did I scroll? That was weird. I never knew I could do that. We are trying to find angle A here. So I'm going to subtract 112.6 from both sides. And I'm going to end up with A equals 180 minus 112.6, 67.4 degrees. And that goes up there. So there we go. I just found my remaining two angles. Now, if I were to kind of spell this out in a step-by-step, essentially what I did is I first used my law of sines to find my first angle, and then I used just the interior angles theorem of triangles in order to use my knowledge that all three angles add up to 180 in order to find the second angle. Alright, so let's follow that same process and do it for this second problem here in your notes. So here we go. Starting, identifying, we've got angle B, which corresponds to the angle of 77 degrees, and that corresponds with the side of 9. Angle C corresponds with the 6, and angle A corresponds with really an unknown side length. So we can't start with A. We can't start with A because we don't know anything about A or its opposite side length, the corresponding side length. So it's useless to us right now. Now I'm not really caring about what that side length is, so I'm just going to ignore that for now. Now, that means that we know that angle B is 77 degrees, and we know that its corresponding side is 9 degrees, so that's going to be used for sure. But then we also know the corresponding side length of C, which is 6, but we don't know what angle C is. So we're going to try to solve for angle C first. So like we say, we always start in the top left with what we're trying to find. And in this case, it's the angle C. So we're going to do the sine of C divided by its corresponding side, which happens to be 6. That is equal to the sine of 77 degrees divided by 9, because that's our angle side pair that we know both of them of. We only want one unknown piece here, and that is angle C. That's what we're trying to find here. So let's move on. Next step is taking the inverse, is multiplying both sides by 6. So 6 times the sine of C divided by 6 equals sine of 77 degrees divided by 9 times 6. That cancels out on the left side, and we are left with the sine of C is equal to 6 times the sine of 77 degrees divided by 9. Now, as you all know, the way that we, wow, I'm so sorry, this looks pitiful. We all know that if I want to try to isolate C, I need to do the inverse sine of both sides. So let's do that. So sine to the negative 1 of the sine of C, that is equal to the sine to the negative 1 of this entire thing, which let me calculate what that, let me calculate what this number is. So 6 times the sine of 77 gives me 5.846 divided by 9 gives me 0.64958. So 0.65. So 0.65. And that leaves me with angle C is equal to, so on my calculator I'm going to do inverse sine of 0.65, and I get 40.54, so 40.5. And that is my angle C. Now, from previous experience, like we were describing earlier, we can use the fact that the interior angles of a triangle add up to 180, and I'm just going to jump right to the good stuff and say 180 degrees minus 40.5. Actually, you know what? I'm going to take this a different route. We'll set it up the same way that we did before. So 40.5 plus 77 plus angle A should equal 180 degrees. 40.5 plus 77 is going to give me 117.5 plus A equals 180 degrees, and 117.5, subtracting that from 180, 40.5. And that gives me 62.5 degrees. So A equals 62.5 degrees. So that's angle A. This goes all the way up there. And there we have it. We found our remaining angles A and C. We're all set. So feel free to pause, replay, rewind, whatever you got to do. But basically, the steps for solving for an angle would be step 1, use law of sines to find one of the missing angles. And then 2, use the known angles, which is going to be 2 of them, and the fact that interior angles of a triangle add up to 180 degrees to find your last angle. And then you are a happy camper after that. So, anywho, this is the remainder of your notes, and there will be an assignment for you to submit the remainder of your notes, and then to go on and practice the rest of your law of sines practice. And you know what? I actually decided just in this moment, I'm not going to have you submit the notes, but I do need you to fill those out still. But I'm not going to go through the hassle. I'm not going to make you go through the hassle of turning that in on Moodle. Because I believe that the assignment I'm going to give you will be a worksheet, because I don't think Delta has problems for this. So I'll look more into that, but you guys are awesome. I'm approaching 20 minutes on this video, which is about perfect timing. And yeah, I will see you on the Google Doc to answer any questions that you have. Yeah, thanks guys for all your hard work.